to do the problems and how to answer them. So for this project, what they do is they say they're doing target practice, and there's a carnival game that uses a 10 by 10 dartboard, this section here, with targets. Each player throws a dart at the board and wins a prize if the dart hits the target. Okay, so let's see. Here's the first question. It says one target is a parallelogram as shown. That is our parallelogram. Find its area to the nearest square unit. Okay, so let's recall. If you have a parallelogram, maybe you have this in your notes. If not, we'll go over it. The area of a parallelogram is the base times the height. Okay, now the base can be any of the sides. I'm going to choose this one because it goes from a corner to a corner, and I can just count the units. So it has a length of 1, 2, 3, 4, 5. Well, that's my base. The height is the distance between the two, so the distance between these two parallel sides. So they are 1, 2 units apart. Notice if I draw a line in there, the distance between them, that's my height right there, is a height of 2. Okay, so the area of this parallelogram is 5 times 2, or 10. And those would be 10 square units. Okay, the second question in the project says this: which of the following may be the coordinates of C such that the triangular target ABC has the same area as the parallelogram? So remember, we figured out in the last question the area of our parallelogram. It has an area of 10. Okay, it was 5 times the height of 2. Well, let's take a minute and think. We're going to end up with a triangle here. So we want it to have the same area as the parallelogram. The parallelogram's formula for area was just base times height. But when you think about a triangle, its area is the base times height divided by 2. Right now, our triangle, we haven't formed yet, has a base of 5, just like our parallelogram. So what would its height have to be to come out with the same answer? Okay, well, we need the height to be, if you can think about it, it needs to be twice as high so that when we divide by 2, we still end up with the same number. So that's one way to look at this. This had a height of 2, so our triangle needs to have a height of 4 so that it's twice as tall and can end up with the same area when you're using your formula. That's one way to look at it. The other thing that you can do is try each of these vertices and see which one gives you the right answer. Okay, so if my vertex is at 1, 3, and I just go ahead, you can always do trial and error. So let's say C was at 1, 3, and I had this triangle. What would its area be? Well, the base is 5, the height is, count the units, 1, 2, 3, 4. Okay, what would its area be? Well, for a triangle, you do base times height divided by 2. 5 times 4 is 20. 20 divided by 2 is 10. Did we get the same area as our parallelogram? We did. We knew the parallelogram from our last question had an area of 10. If we use 1, 3 as that point C, we get the same thing. Well, I got lucky and got the right answer on the first trial and error. So let me show you what would happen if it were not correct. So let's try one of these other points and see what happens. Let's try the point 3, 4. Okay, so where is the point 3, 4? It's over 3, up 4. Okay, that's our C, and we draw this triangle with A, B, and C in it. And we need to find the area of that triangle, see if it's 10, like our parallelogram was, because that's what we're shooting for. Well, to find the area of a triangle, you have to have the base, which is still 5, and the height. Now the height has to go directly from the base to the point, and it needs to make a right angle. Okay, so that would be our height. How high is it? 1, 2, 3 units high. So if I found the area of the triangle from this point, it would be the base is 5, the height is 3, base times height divided by 2 gives me 15 divided by 2, or 7.5. Okay? So the area of this triangle is 7.5 if I use the point 34 as my point C. That is not going to work. We wanted it to have the same area as the parallelogram, and it didn't work. So that's what it looks like if you're doing trial and error with the points and it doesn't work. Unfortunately, we didn't get to do many because our first point just worked out. When we used 1, 3, we had a triangle that had the same area as our parallelogram. But if it hadn't worked, we would have just gone through, tried all of these points until we found one that did.